Good afternoon, Lee County, and welcome to this special edition of Lee Schools TV as we present to you the solar eclipse across America. I'm your host, Lee Hughes, Program Administrator in Intervention Programs, and joining me live on the phone is Mr. Aaron Risch, Science Teacher at Caloosa Middle School. Mr. Risch, why don't you tell us where you're reporting from?
I am in Jefferson City, Missouri, just on the outside of town, close to the center of the eclipse path.
And how are you bringing us these pictures?
I've got a telescope hooked up to an astro camera, and then I am streaming it to a website that's made for live astronomy.
So those of you in our schools here in Lee County, if you're watching, depending on different feeds, you might have noticed that over on the West Coast, over in Oregon, they're actually closer to the totality of this solar eclipse. And what you're seeing from Missouri, where Mr. Risch is located, is the moon has already made first contact with the sun. The moon is now passing in between the sun and Earth and is therefore starting to block the sun and cast a shadow on the Earth. Mr. Risch, tell us what's been going on today and so far in Missouri.
So the eclipse started about 45 minutes ago. Started with just a little bite taken out of the sun. Now we're at about maybe 40%, 40% of the way in. We're getting closer to totality. You can see sort of a crescent shape on the screen. Around here, if you also look at the leaves on the ground, or the shadow, I should say, of trees on the ground, the little spaces between the leaves right now are casting these crescent shapes on the ground also. The sky is still really bright because the sun is still very bright, even partway into an eclipse.
We want to let all our viewers know that here in Southwest Florida, we are experiencing eclipse today. However, we're going to see a partial eclipse. And part of that is because of the distance that Southwest Florida is from the center path of the eclipse path. We're going to see about a 76% eclipse of the sun, whereas where Mr. Risch is located in Jefferson City, Missouri, he's going to see a 100% total eclipse. And Mr. Risch, why is that such an important phenomenon compared to what we're seeing here in Southwest Florida?
The total eclipse is the only time that you can see the sun's corona and some of the prominences on the sun without really special instruments. The corona is the outer atmosphere of the sun, and normally it is drowned out by the brightness of the sun's surface, the photosphere of the sun, where all the light appears to be coming from. So it's normally drowned out from there, and with the moon blocking out the photosphere, you can see the corona illuminated. This will also allow us to see the stars come out because the sky will be completely black, like at nighttime. And they were able to test general relativity using that because it's the only time you can see the stars around the sun in the daytime.
And what's pretty neat about this particular event is it's been almost 100 years since North America last experienced a total eclipse going over the 48 contiguous states. Just so you know, a little factoid about solar eclipses, they happen about every 18 months here on Earth, but because of the amount of land on Earth and also because so much of Earth is covered by water, not everyone sees the solar eclipse, depending on where you live and where you're situated. We've got some questions coming into us. You can certainly email us your questions here at news@leeschools.net. Again, we're here to answer your questions, so if you want to email us your questions, you can email us at news@leeschools.net. And I do have a question coming in from one of our students. Madison asks, what shade glasses do you wear to be able to view the eclipse in person? Aaron, can you tell us about your equipment?
Hi, Madison. Yeah, the glasses that I have, they look completely black. You can't see anything other than the sun through them. And when you do look at the sun, it just looks like an orange circle. On my telescope, where I've been getting my feed from, there's a solar filter that almost looks like aluminum foil. So it reflects most of the sunlight back away, and it only lets a little bit through into your eye.
And are those special rated glasses or shields that you're wearing?
Yeah, they have to have a special rating for the glasses. And the solar filters, they sell those, telescope companies sell solar filters that you can put over your telescope.
And we also want to caution all you students here in Southwest Florida and in our Lee County schools that if you're using glasses, you want to make sure those are the approved glasses to view the solar eclipse today, because we want to protect those eyes against the sun rays. Some more questions coming in. Why does the solar eclipse damage our eyes? And this is from Miss Cessna's class at Bonita Springs Elementary.
So the solar eclipse itself doesn't damage your eyes. It's just the sun that damages your eyes. Anytime that you're looking at the sun, it's so bright that it damages your eyes. The only reason why people are more worried about eye damage during the solar eclipse is because more people are going to be looking at the sun during the solar eclipse. There are going to be people who are going to try and look straight at the sun. So there's just more people looking at the sun, which causes more eye injuries. But it's never safe to look at the sun, not even during a regular day.
Now, Mr. Risch, is it crowded where you're at?
Let me see. 1, 2, 3, 4, 5, 6, 7, 8. I think I see about 8 other vehicles besides mine.
And what was traffic like this weekend getting up to your location?
Traffic actually wasn't bad, but I left really early in the morning. Anytime you need to see an eclipse, you leave early in the morning.
We have a question from Johan asking, is it safe to record the eclipse with a 4K Nikon camera that has no solar filter? Mr. Risch, would you like to reply?
You should have a solar filter on any camera. Just like you risk damaging your eyes by looking straight at the sun without glasses or a filter, you also risk damaging your camera. There's a little sensitive sensor in there.
Another question coming to us from Addison. Addison asks, what does the solar eclipse look like? Well, if you look on your screen now, we have a feed where the moon is actually passing in between the Earth and the sun. It's sort of like casting a shadow. And so as the moon travels on its path, it's going to cover up more and more of the sun until eventually you'll just see that corona or that halo of light around the outside. In spots like where Mr. Risch is located, it's going to go from pretty much complete sunlight to just about complete darkness. And then there'll also be other celestial objects in sight lines, including 4 planets today that'll be visible when the total eclipse occurs. And then likewise, as you're seeing the moon move into position, blocking the sun, the moon will continue to move out of its path and out of the path of the sun. And you'll start to see more and more of the sunlight reemerge on the other side of the moon. So we'll go from sunlight to darkness and then back to full sunlight. Here's a good question coming to us from Isabella. How long will totality last? Mr. Risch?
That's a really good question. Totality, how long totality lasts is actually going to depend on where in the eclipse path you are. Where I am, it's going to be about 2 minutes and 30 seconds, give or take a few seconds. The maximum for this eclipse is 2 minutes and 40 seconds. The further you are from the center of what's called the path of totality, the small path across the country, where the totality happens, where the moon completely comes between the sun and the earth. On the outside edges of that path, you can sometimes only see a few seconds, 20 seconds of totality. The world record for the longest totality ever was about 7 minutes.
Yeah, that actually is a good segue to a couple of news stories that we pulled down. A team of NASA scientists are actually up in chasing the eclipse today. They're using telescopes on board 2 NASA research jets that are going to make thermal maps of Mercury during the eclipse. That's significant because Mercury is so close to the sun that it's often too hot to use some scientific instruments to make recordings. So what they're trying to do is record a thermal map of the planet Mercury, and they're doing that with special equipment that's housed on those jets. They're flying at approximately 50,000 feet over Missouri, Illinois, and Tennessee. And they're actually going to stretch the amount of time that they can see the totality because they're flying. One is flying ahead of the path of that eclipse, another plane is flying behind. And because they're up in the air as opposed to grounded on land, their totality is going to reach a little over 6.5 minutes. So, a cool fact about that project that's going on from NASA as they chase the solar eclipse. Some more questions coming in. This question is coming in from, let's see, looks like Asia. Asia is a first grader at Heights Elementary, and she'd like to know if the moon can cover planets also. Do we ever have incidents where the moon actually causes an eclipse or a shadow and blocks us seeing planets? Mr. Rish, would you like to add?
Hi, Asia. Yes, the moon definitely does cover up planets sometimes. Since the moon is so big in the sky and the planets are so small, and also stars in the sky look so small, even though they're really big, they're far away. The moon can cover up planets and the moon can cover up stars in the sky. When that happens, they call it an occultation.
Another question coming to us from Morgan. Morgan asks, how often does solar eclipse occur? Well, as I mentioned earlier, somewhere on Earth, about every 18 months, there's a solar eclipse. The other types of eclipse we have is a lunar eclipse. And a lunar eclipse occurs when the Earth passes in between the moon and the sun, and Earth's shadow blocks, or I should say, Earth casts a shadow on the moon. And so that would be known as a lunar eclipse. As we mentioned, this eclipse is significant because it's the first time in almost 100 years that a total solar eclipse has passed over the 48 contiguous United States. Something to know, though, there are 2 more solar eclipses coming in the future. There's going to be one in 2023. There's also another total solar eclipse in 2024 that is going to have a pathway that goes from about Texas all the way up the eastern coast to Maine. So that's something to plan for in case you missed this one and you want to see the next total solar eclipse. You'll be looking for that event in 2024. Camilla asks again, how long is this total eclipse going to last? Mr. Rish, would you please elaborate?
Hi, Camilla. So the whole eclipse will last a few hours. The eclipse here started around 11:45 my time, and it's going to be about halfway done around 1:15 my time, which will be 2:15 your time. And then it'll be about the same length until the end. So the full eclipse lasts a few hours. Totality lasts about 2.5 minutes here where I am.
And again, if you're just joining us, we are at Lee Schools TV. We're doing a live broadcast of the solar eclipse across America. Joining me on the phone is Mr. Aaron Rish, middle school teacher from Caloosa Middle. He is joining us from Jefferson City, Missouri. He's taking footage for us, but also at this time you're seeing in the panel some live footage from the NASA feed. What you're seeing is more and more of the moon traveling in front of the sun. It's starting to block out, I'd say, about 50 to 60% of the sun, heading towards that totality event that, as Mr. Rish just said, only lasts for about 2 to 2.5 minutes, depending on where you are viewing the eclipse on the pathway. The other thing we want to remind our students here in Lee County that we're only seeing a partial eclipse. We're not going to have that full totality event. We're seeing about 76% of the solar eclipse. But nonetheless, if you are viewing the eclipse, we want to make sure you have your safety glasses on. Those should be approved safety glasses. You'll want to look for a label that says AAS as far as the approved label for those safety glasses. Let's see. Lindsay has a question for us from Fort Myers Middle Academy. And Lindsay asks, why does the moon cover the sun? Mr. Rish, would you like to elaborate?
Hi, Lindsay. So you know that the Earth goes around the sun and the moon goes around the Earth. And as the Earth is circling the sun, the moon goes around and around the Earth. And sometimes as they're going around and around, the moon will go between the sun and the Earth. And when that happens, it blocks out the sun. Right now, we're at the time of the moon cycle called a new moon. You've seen the different types of moons, crescent moons and half moons and full moons. The new moon is when the moon is completely black. Normally, a new moon doesn't block out the sun completely because they're at a funny angle, but when it's just right, the moon will move right in front of the sun.
And I'm just viewing our inbox. Again, you can send us your questions to news@leeschools.net. Once again, send us your questions to news@leeschools.net. So a question from Zachary. Zachary asks, what happens to the sun when the moon covers it?
Hi, Zachary. Well, the sun's still there when the moon covers it. We just can't see it. Nothing special happens to the sun otherwise. We just can't see the sun.
Another question coming to us from Sally. Sally, Miss Key's class at Heights Elementary wants to know, how far away is the solar eclipse?
Hi, Sally. So the solar eclipse, the moon where it is right now, it's somewhere between 200,000 and 300,000 miles from the Earth. It takes about a second and a half for moonlight to get to the Earth, so that's how far away it is. That's where the moon is, and then the sun is much further away. It's about 93 million miles away. So the sun and the Earth are actually very far apart, but when we're looking at them, they look really close together in the sky right now.
And Mr. Risch, there have been some reports, and scientists have speculated, there's been anecdotal evidence going back several hundred years that animals behave differently during an eclipse. Would you like to elaborate?
Yeah, so the animals don't know about the eclipse. The animals just know that it's gotten dark, and so the animals start getting ready to go to sleep at night. The nighttime animals start coming out. You might hear some owls hooting. I hope I hear something like that out here.
And are you, even though, again, we're moving towards that totality event, which is expected here local time at 2:15 p.m., I know that's 1:15 local time where you're at in Missouri. Are you starting to notice a temperature change because of the eclipse?
Yes, it is starting to cool off a bit. I brought my thermometer with me because scientists always want to record their observations. It was about 85 degrees. Sorry, it was about 90 degrees when I got here. Now it's down to about 87 degrees. It was 88 degrees last time I checked.
Okay, I got a series of questions coming to us from a fourth grade classroom. We'll start off with, what does the solar eclipse do to the Earth?
The solar eclipse doesn't really do anything to the Earth other than it casts the moon's shadow down onto the Earth. If you can see the total eclipse, you're in the path of the moon's shadow. So it makes a little round shadow of the moon on the Earth.
There are some other reports, too, that there's scientists all over the United States that are studying what happens to the Earth's atmosphere. As you know, with direct sunlight, that's going to charge the ionosphere of Earth, and that's where a lot of radio waves travel, are deflected, or diffract through the atmosphere. And so one of the reports was scientists were studying what happens in Earth's atmosphere. And so there's people all over the United States who are using their radio transmitters and receivers to try and see if there's any type of change in the frequency of those wavelengths and those radio waves.
Right, we would be in sort of like a radio shadow.
Yeah, and so it'll be interesting to see if a lot of this data is going to come out after the eclipse. And I guess the other thing to point out too is really what's happening is the moon is casting a shadow on Earth, and that shadow is moving across the United States. Started off in Oregon State. It's now heading east towards South Carolina, and in about an hour or so, almost 2 hours, is when the event will start to subside. Checking the board, we have a couple other questions. Why does the sun look red? I think some of our viewers are looking at different feeds and they're seeing the sun looking so red during the solar eclipse. Mr. Risch, how's the sun appear to you?
The sun is going to be a different color depending on what type of filter you use. There are lots of different types of filters. The one that I have on my telescope is a white light filter, so it gives me a white sun. I've got another filter at home that I didn't bring with me. because it goes with another telescope, and when I point that at the sun, I get an orange sun. My solar glasses are giving me an orange sun right now. Up in the sky, the sun is still super bright, so you can't look at it, but it's making about the same color sunlight as usual. It is starting to get a little bit darker here, it feels like.
And bear with us as we get to your questions. Those questions are coming into our email box. That is news@leeschools.net. I've got a good question here based on our conversation a few moments ago about those NASA jets that are doing some research. Matthew's question is, how is an airplane pilot able to fly in the sky during a solar eclipse? Well, again, as we mentioned, whether you're where Mr. Risch is located in Missouri or you're here in Southwest Florida, if you're viewing the solar eclipse, we want you to make sure you're wearing your safety glasses. And I got to imagine today, if there's airline pilots out there taking their flights, they're also using safety glasses to navigate, to see where they're going, but also because they don't want to be blinded by the sun's rays as they're looking at these events. It also helps they have some autopilot features on those planes, and I'm sure those are kicking in today as well. But those researchers for NASA, chances are they have safety equipment. That equipment's usually built into their helmets with the appropriate shield or vision, and they're using that equipment to stay safe today. Mr. Risch, what's going on in your neck of the woods right now?
Right now, like I said, it's starting to look a little bit darker. It seems also like the light around me, the scene around me, is starting to take on a little bit more of a yellowish kind of a sunset type of color. And that's because actually during the totality, there's going to be a 360-degree sunset. The whole horizon is going to look kind of like the colors of sunset. And we're starting to get that right now.
We got a two-part question from Fort Myers Middle Academy. This is a good one. This speaks to approximately how many miles are you from us in Southwest Florida, Mr. Risch?
I did not check on my map exactly how far I am, but I can give you an idea how long it took to travel here.
Sure.
It took me about an hour and a half on my first flight and about an hour and 40 minutes on my second flight. I went to Atlanta and then to Kansas City. So I'm about 3 hours away by airplane.
So Joel from Fort Myers Middle asks why we can't see the total eclipse here in Florida. And part of that has to do with the path of the moon, and that the moon is orbiting Earth. And so based on that pathway the moon is taking, that's going to dictate where in the United States the total eclipse is occurring. We're several hundred miles away from Missouri, where Mr. Risch is located. So that distance means that we're not seeing the 100% total eclipse, but we're seeing a partial eclipse. Approximately 76% of the sun will be blocked by the path of the moon as it moves in between Earth and the sun. And then Sheldon asks, does the path of the solar eclipse change every time? Mr. Risch?
Yes. Every time the solar eclipse will have a different path, or mostly a different path. Sometimes it'll go over the same country. Like in the year 2024, 7 years from now, there will be another eclipse that goes over America. But most eclipses don't go over the United States. So they have very different paths each time.
Yeah.
Little bit of news here for you also. Some of the street lights have started coming on.
That's pretty cool. And so a lot of those street lights would be on sensors. So it must be getting dark enough that those lights are being triggered. Just want to let you know we are having a little bit of technical difficulty with Mr. Risch's feed, but we are switching back and forth between a NASA feed and also other feeds that are in the Springfield, Missouri area. So as you're watching us on TV or watching us on YouTube, you're seeing a couple of different feeds come in that are showing the solar eclipse and as we move towards that totality event. And again, as we mentioned, related to that question from Fort Myers Middle Academy, the next major solar eclipse is going to be 2024, and that's the path of the moon during that eclipse event is going to run its course from Texas all the way up the eastern United States to Maine.
And if you can wait until 2045, there will be an eclipse that goes across Florida.
A couple more questions. This one from Hayden Scott wants to know, when the next solar eclipse will happen, and what is the best state to see the eclipse. Well, actually, there's a town in, and I'll get it for you. There's a town in Illinois that this total eclipse is going to pass over, and that same town, Carbondale, Illinois, will get a chance to see the solar eclipse in 7 years. So if you were looking to study the sun and the effects of solar eclipse and wanted to see a full cycle between eclipse, you'd want to be in Carbondale, Illinois today, and then go back there in 7 years' time to see that next solar eclipse. Are you noticing any differences in animal behaviors as it gets darker in Missouri?
There were some cicadas, those really loud buzzing insects that were making a lot of noise when I first got here. They're starting to quiet down because they do quiet down at night. And I'm starting to hear what sounds like crickets or something too. So I am hearing different behavior in the insects right now.
Another question coming to us from Miss Davis's class, and just want to reiterate, they ask, how often does a solar eclipse occur? Well, again, on average, about every 18 months, there's a total solar eclipse. It just depends on where on Earth you live and whether or not you're on land in order to see it. Oftentimes, these eclipses happen, and the shadows that are cast by the moon on Earth fall over water, and so therefore may go unnoticed. Another question coming to us from Mrs. Edwards' class at Diplomat Elementary, thanks for emailing in, is a solar eclipse similar to a lunar eclipse? And we'll go ahead and recap that answer. No, they are different events. In a solar eclipse, the moon is actually moving between sun and the earth. And so the moon casts a shadow on the earth, and that's why it's called a solar eclipse. In a lunar eclipse, the Earth is actually traveling between the sun and the moon, and it's Earth's shadow that is being cast on the moon, and that oftentimes is best seen in the evening time, but also can be seen during daylight or dusk hours. Another question to us about safety glasses. Does the glass have to be NASA approved? Yes, NASA has approved some glassware and safety glasses, but the other organization is AAS or AAS. They're an astronomical society, and they've also approved some safe glasses to wear. Question to us, Mr. Risch, will the moon look different tonight?
You won't be able to see the moon tonight. The moon will be a new moon, which is the point where the moon is black. So you won't be able to see it. In a few days, you'll be able to see a very thin crescent moon. Right now, with the moon between us and the sun, the part of the moon that's being lit up by the sun is facing away from us. We're seeing the dark side of the moon.
Here's an interesting question that maybe takes us in a little bit of a literary direction. Mr. Risch, do you know any interesting myths associated with solar eclipses?
Yes. There's the ancient myth of the dragon that eats the sun. So they thought that there was this dragon trying to eat the sun, and then the sun would get away from the dragon. The Egyptians had a myth of an ancient battle between Ra and Apophis, his enemy. Ra was the sun god, and Apophis was like a god of night and the underworld and darkness. And when the eclipse happened, they thought that Ra and Apophis were having a battle. There's also a Greek myth of Apollo's son who steals his chariot and tries to fly it across the sky, and he messes up and causes a lot of chaos. So Zeus hits him with a thunderbolt.
Another question coming to us from Madison. How is the eclipse more intense and more dangerous than the regular sun? Well, actually, that's a little bit of a misconception. The sun is very powerful. The sun produces a lot of energy each and every day. And so even though we can't see the sun's direct sunlight during this eclipse event, the sun's still there. The sun's still producing energy. The sun at its core is still several million degrees. Near the corona, the sun is anywhere from about 5,500 degrees Celsius to almost 10,000 degrees Celsius, just the area outside the corona. So the sun is still very strong, very powerful. The sun's rays are no less or no more powerful today. That's partly why we advise that people wear safety glasses when they view the eclipse, because ordinarily we don't stare at the sun. But because today there's so much attention put on this solar event, and a lot of people will be looking to the skies, we want to make sure everyone's safe, because oftentimes you can't detect the damage that the sun's rays could do to your eyes. And so again, we want to make sure that if you are viewing the eclipse, whether it's the total eclipse in the middle part of the country or the partial eclipse here in Southwest Florida, we want to make sure you're wearing your safety glasses. Mr. Risch, are we getting closer in your area to totality?
We are getting much closer. The sun just looks like a real thin moon shape right now. It's getting close, and it is getting cooler by about a degree every 15 minutes. So the eclipse here should happen around, or the totality, I should say, should happen around 2:15 your time. So we're almost getting to that time.
Yeah, we're about 11 minutes from that. How about the winds? Have the winds picked up because of the change in temperature?
There was a little breeze earlier. I am expecting a bit more of a breeze as we get even closer to totality. And the breeze does have a chill in it.
We have a question from the Alva School. Hello to Miss Stinson's classroom. Are there any other continents besides North America today who are witnessing the total solar eclipse?
Right now, the eclipse is only going to be across the United States of America on the North American continent.
Now, as we get closer and closer to the totality event, a couple of features we're looking for. One is something called Bailey's bead. Bailey's bead is just prior to totality. All that remains of the sun are a few shafts of light that are shining through the deep valleys on the lunar edge of the moon. So the result is a few brilliant beads that disappear one after another, almost like a necklace, like a pearl necklace. So you're going to see those beads of sun. And I believe if you look at the feed that's on display right now from C-SPAN, you're seeing a vision of that Bailey's bead coming to us from Nebraska. The result is a few brilliant beads that disappear one after another. The result, if you're using a telescope or binoculars to observe the beads, you want to make sure you keep your solar filters on. All right. Again, only during totality could you actually take off your glasses, and that's only in the zone of the total path of the solar eclipse. Here in Southwest Florida, we're seeing a partial eclipse. That means the sun's rays are still shining down. It'll get darker, but not complete darkness. So we want to make sure for all of you out here in Southwest Florida, if you're watching the total eclipse, you're seeing a partial eclipse, and we want to make sure that you are wearing your safety glasses. Mr. Risch, you want to tell us about the diamond ring that we'll be seeing?
Right, so the diamond ring is the very last bit of sun to get covered up, or at the end of the totality, the very first bit to get uncovered. And so it just shows up as a really bright point of light, like a diamond on a ring.
Another question coming to us from Courtney. Courtney asks, can you use binoculars with appropriate lenses for the eclipse? Mr. Risch, when would it be appropriate to just use binoculars?
During totality, you can just use binoculars. But remember, the totality is very short, so you wouldn't be able to look for very long. And you'd have to make sure that you take the binoculars away from your eyes before totality ends so that the light doesn't come into the binoculars and hurt your eyes. Otherwise, you can watch any point during the eclipse with binoculars if you have the right filter on them. I will say it's not safe just to put your sunglasses or your solar glasses on, your eclipse glasses on, and try and look through binoculars there, because the binoculars are more powerful than your eyes.
And just want to reiterate that we are live here on Lee Schools TV. We're bringing you a special presentation on the solar eclipse across America. Joining me on the phone live in Missouri is Mr. Aaron Risch, science teacher at Caloosa Middle School. We are also taking your questions. You can email us your questions to news@leeschools.net. Question coming to us from Trent. Trent wants to know, in Missouri, how long does it take for the solar eclipse to occur?
The entire eclipse takes about a few hours, so about 3 or 4 hours. But the totality is about 2.5 minutes where I am.
And a couple questions coming to us again about safety equipment or using sunglasses to view the eclipse. We want to warn you not to use sunglasses to view the eclipse. Sunglasses don't have a special filter or layer on them to be able to block out those harmful UV rays from the sun. If you're viewing the solar eclipse today, whether it's here in Southwest Florida or in the middle part of the country where there is a total solar eclipse, we want to make sure that you are wearing your approved safety glasses. Those glasses should either be NASA approved or AAS approved, but you want to make sure you're using that safety equipment. Here's a good question from Isabella, and it's kind of funny because if you've seen The Rock in the Apple commercials lately, I think he takes a selfie and then says, "I hope I don't cause an eclipse." How would the solar eclipse affect astronauts in orbit nearby?
It would depend on where the astronauts are in orbit. If the astronauts are passing through the path of the sun or through the path of the moon's shadow, then they would be in total darkness. They wouldn't be able to see the sun, so they'd be able to see an eclipse similar to what we see on Earth. But normally, the astronauts in their spacecraft are going to be far away from that path of totality, and they would not be able to see anything other than the regular sun. Speaking of which, we've got a very thin crescent sun right now. We are almost covered up.
Okay, so we are moments from that totality event. Again, the projected time for totality is 2:15 local time, 1:15 in the Midwest. As you can see, you have just a crescent of the sun appearing. Oftentimes when we look to the night sky or in the morning sky, we'll see a crescent moon, but it's not very often you're going to see a crescent sun. And as they say, this is a once-in-a-lifetime event because most total solar eclipses happen about once in 100 years. But as we mentioned, total eclipses happen every 18 months, but it's whether or not the eclipse event happens over land. So oftentimes these eclipses happen and we don't see it because it does not happen over land. It may happen over water. And Mr. Risch, what are you experiencing now as we get closer and closer to totality?
So it is starting to get much darker here. It's about the brightness of a sunset when the sun has already gone down. It's dark around me, and the sun is almost gone. The light around me is still kind of orangey because it's that 360-degree sunset effect. The area where the eclipse is coming towards me, that sky is dark. It almost looks like a storm coming, but it's not a storm. It's just the shadow of the eclipse coming.
If you're watching us and watching our live feed, you can see that there is a special lens on the cameras that are being used to film the eclipse. So that may not give you a sense of the darkness, but Mr. Risch, would you say it's almost like sunset?
Yeah, it's like sunset, or maybe even after the sun has just gone down a little bit, but the sky is light. And I am seeing a lot of sunset colors around the sky now. It's looking really gloomy here.
And a question to us from San Carlos Park Elementary School: how dark will it get in Lee County? Will it affect the light on the moon? Well, again, we're not experiencing a total solar eclipse, so for our area, we won't go from that light to total darkness back to light, but it'll get darker, kind of like it would on a cloudy day. So you'll see a reduction in sunlight in our area. And then as far as the light on the moon, well, we're in a new moon phase, so that means that we're seeing the dark side or the back side of the moon. And so the sunlight is still shining on the moon, on the other side of the moon that's facing the sun. The moon is getting that full, the full array of sunlight. It's just that we're experiencing a shadow from the moon being cast on Earth. Okay, and
All
again,
right, this is it. Totality is coming. It's getting real dark here, real quick.
so again, 2:15 is when we're expecting that totality event. We are now at
And there's the
2:13.
diamond ring. That's it.
So diamond ring is starting to happen.
And there is the total eclipse. It looks amazing. So I can see the corona really well now. The corona is that outer atmosphere part of the sun. And the corona is getting brighter and brighter as it gets covered up. And it just looks like a really dark night sky, sunset around me, 360 degrees. The whole horizon looks like sunset. I can see stars. I can see the clouds. Somebody's shooting off fireworks. And yeah, the corona looks really exciting. I'm just watching it right now, trying to sketch what I see. I'm going to see if I can get a picture.
So as you just heard, Mr. Aaron Risch, middle school teacher from Caloosa Middle School, he's joining us live from Jefferson City, Missouri. Jefferson City right now is experiencing the totality event of this solar eclipse. That means that the moon, for the next 2 minutes, for approximately 2 minutes, is going to be remaining right in front of the sun, completely blocking direct sunlight to Earth. All that's visible is that corona. It's during this moment in time where you could take off your safety glasses if you're in the path of the total eclipse. Again, if you're in the path of the total eclipse, you could, for the next moment, about 2 minutes, you could view the sun and that corona that's existing around the moon. Again, the corona is the outermost edges of the sun. The sun is completely blocked right now by the moon. And we're in that totality event, which will last for approximately 2 to 2.5 minutes. And then we'll start to see the moon exit to the other side of the sun, and we'll start to see more and more sunlight. Okay. Once again, thank you for joining us this afternoon. We are Lee Schools TV, and we are live bringing you this special event, the Solar Eclipse Across America. My name is Lee Hughes. I'm a program administrator in our interventions program. I'm your host, and we are having some technical difficulties with Mr. Risch's phone. We're going to try and get him back on the line, but joining us live.
I'm back.
Oh, you're back. Awesome. Thank you.
I'm back.
So how's the corona look?
So totality is over. The corona was very bright. It was almost like, well, corona means crown in, I think it's Greek or Latin. And it did kind of look like a crown around the moon. It was a bright circle of sort of fuzzy light around the sun, and that was the sun's atmosphere, which you can only see when it's fully covered up. So what I'm seeing now is it's starting to brighten back up very quickly around here. It's starting to look a bit like a sunrise now, actually, with the way that it's getting brighter and brighter around here. It's getting brighter very quickly. Just as quickly as it got dark, it got bright very quickly. There's still a tiny crescent of the sun, so I had to put my glasses back on. But it's brightening up here. I heard a few animals kind of quiet down, some of the bugs and stuff. The night bugs started making noise. Some of the daytime bugs really quieted down. But now it's all coming back.
So, Mr. Risch, can you see any planets in the night sky?
Yes, I did see a planet. I'm not sure exactly which planet it was. I'd have to check a star chart. But I did see a very bright planet. There were some clouds around here, so it clouded up a little bit of the stars. But the clouds didn't make that much of a difference to the sun. The corona of the sun is still about as bright as a full moon. So you could still see it really nicely through the little kind of poofy, hazy clouds we had here.
Yeah, for those of you viewing in Southwest Florida, again, we're not going to see a total solar eclipse. We're going to see about 76% of the eclipse. But it might be possible to see Venus. So if you see a bright star in the sky, that could very well be Venus. The other planets that are viewable during this eclipse event are going to be Mars and Mercury. And also you could see Regulus, which is a star in the formation Leo. Okay. Okay.
And during totality, the temperature had gone down to about 85 degrees. So during the entire eclipse, we dropped about 5 degrees temperature.
Okay, Mr. Risch, how are the other spectators in your area taking in? What are they thinking about the eclipse?
I heard lots of oohs and ahs, lots of people really excited about what they were seeing. And like I mentioned, there were some fireworks that somebody was shooting off somewhere. I could hear them going off. Not sure why you would want to watch fireworks when you got the natural show up there, but to each his own.
And how about for you personally? Is this your first eclipse? How would you
This
describe
is
your
the
experience?
first time that I ever saw a totality. Back when I was in middle school at Trafalgar Middle School, we saw a partial eclipse, but this is the first time that I've ever seen a total eclipse from the path of totality, with the moon completely covering up the sun.
So now, just to let you know what's going to be happening with the rest of the eclipse event, you already saw the first contact. That's when the moon first started to move in front of the sun and blocking the sun. The second contact was when the moon reached across in its path and touched the other side of the sun. Again, I say touched, but actually blocked the full sun, and that's when we moved to that totality event. Now the moon is continuing on its path and will be moving to the other side of the sun. So you'll see a third contact, which is another chance for a diamond ring. And then eventually you'll see a fourth contact, which means the other side of the moon completely moves away from the sun and we'll be back to a state of full sunlight. Again, those of you here in Southwest Florida, you are seeing a partial eclipse. Mr. Aaron Risch, middle school teacher from Caloosa Middle School, is joining us. He's live in Jefferson City, Missouri, where he just experienced the totality of this total solar eclipse. And how would you say how fast is the sunlight returning to your environment?
It's starting to brighten up really quickly. It's still, you can tell that it's darker than it normally is, but it's much brighter than it was just a few minutes ago. And so it's starting to feel bright, and it feels like this eclipse is going to be over in no time, even though I think I have about an hour until the eclipse is fully over. The way it's brightening up, it feels like it's over.
Back to a couple of our questions from the email box. The question coming to us from Brianna. Brianna asks, does the sun get hotter during this eclipse event?
Hi, Brianna. No, the sun stays the same temperature. Remember, the sun is much, much further away than the moon is. So the moon will block out the sun. It'll get cooler here, but that's just because the moon is blocking out the sunlight. It's just like how it gets cooler at sunset and at nighttime. But the sun itself is about 93 million miles away, which makes it so that the sun is not going to get hotter or colder and doesn't get affected by the eclipse at all.
Another question coming to us from Derek. Derek asks, can we look at a lunar eclipse? And yes, as we've been mentioning, the concern here with this event is it's a solar eclipse. So that means the moon is passing in between the sun and the earth, and the moon is casting a shadow on earth, and because we would be looking up into the sky and looking at the sunlight, that can be very damaging to our eyes. But during a lunar eclipse, the earth actually passes in between the sun and the moon. The earth then is casting its shadow on the moon, and we can watch the entire lunar eclipse without having fears or concerns with our eyesight. And again, going back to the timing of this event, Mr. Risch, how long would you say the totality lasted where you're viewing from Missouri?
The totality was supposed to last about 2.5 minutes, but like anything that's really exciting, it feels a lot shorter. But it was 2.5 minutes of totality here.
And another question, and thank you, students. You've been lighting up this email box. We have 361 messages from you coming in. Where is the best place to view the solar eclipse? Mr. Risch, what would you say? The best place today to view the solar eclipse?
The best place is going to depend on a lot of different factors. The place with the longest totality is somewhere in southern Illinois, but the place where the weather is the best is really the place where you need to go. I was lucky. Today the weather's been pretty nice. There's been some little wispy clouds around, but not enough to block out the sun at all. The place where I was originally going to go until about 2 days ago, I think it's stormy over there right now, so I'm glad I didn't go there. I've heard that Tennessee and Kentucky are having a really good time right now, and they should probably be in totality any minute now. I think Oregon, towards the inland, was a good spot. Generally, you want to stay away from the ocean during an eclipse because the ocean is where a lot of the storm clouds and stuff like that will form, and those clouds will ruin your view.
Another question coming to us from Mrs. Mazzata's classroom at Rama C. Page. You spoke earlier that you felt it was getting cooler, the temperature around you was getting cooler. How would you describe the temperature now?
I think it is starting to get warmer. Let me check my thermometer. I'll walk back over to my car and watch my thermometer. It is starting to feel warmer because the sun is starting to heat everything back up again. Right now, it's about 86 degrees. It's about a degree warmer from where it was a few minutes ago.
Yeah, and for those of you watching on our feed on Lee Schools TV, the reason the temperature is going to fluctuate is that direct sunlight from the sun going to Earth is being blocked. It's blocked by the moon during this eclipse event. And so temperature is going to lag a little bit. So it could be that what Mr. Risch just described, those temperatures might fluctuate here over the next 5-10 minutes. And that's because of that direct sunlight being blocked intermittently. And then as the moon continues to move away on its path, the sunlight will come out and it may warm back up to what the temperature was maybe a couple hours ago. Great job, students. We're now up to 373 questions coming into our news@leeschools.net inbox, and we're doing our best to get through as many questions as possible. Here's a question to us coming from Craig. Craig asks, and Craig is a student at Orange River Elementary, I know plants use sun's light to make food. Can plants make food when the eclipse happens? Mr. Risch, would you care to elaborate?
That's a really good question. Well, the eclipse is going on since the sky is dark and the sun is basically dark. It's about like moonlight. The plants aren't going to be doing photosynthesis at that time. They're going to go in their nighttime mode where they release some of the energy that they stored in the food that they made during the daytime.
Some more questions coming to us from Franklin Park Elementary School. What part of our planet sees the most eclipse? Well, that's going to be it's going to be varied. You want to consider how much land mass. North America is a very large continent, and so we frequently have eclipses. One of the best things to do is a Google search and look for a schedule of solar eclipses. There's also several maps out there from NASA and other sites that'll show you when and where those eclipses have occurred. It's kind of like tracking a hurricane. You look at a hurricane tracking map. Well, you can also look at a solar eclipse tracking map, and that'll give you an indication of when they travel over land and when they travel over water. How many miles wide is the totality? Mr. Risch, correct me if I'm wrong, but I want to say it was somewhere between 70 and 100 miles wide was the path. Is that about right?
Right, somewhere around there. And about where the eclipses are happening the most often, that would basically be over the Pacific Ocean, because the Pacific Ocean is the largest ocean on the Earth. So it's it covers more of the Earth than anywhere else. So eclipses happen more often there than anywhere else.
Another question coming to us on the news@leeschools.net inbox. This question comes to us from Pinewoods Elementary. How long will the sun be completely covered for? And as we just experienced about 12, 13 minutes ago, the totality event only lasted about 2 minutes. And as we mentioned earlier in this broadcast, that there are some scientists from NASA who are flying, literally flying, to keep up with the eclipse, and they're hoping to view totality for about 6 minutes. So, but if you're standing here on Earth and you're in the path of the total solar eclipse, you can expect to see the sun covered, what appears to be covered by the moon, for approximately 2 to 2.5 minutes.
Right. And the moon's shadow moves across the Earth at over 1,000 miles per hour. So those NASA planes, the scientists' planes, need to be flying really fast.
And good job. You just answered Sonia's question. It was, what speed is the moon traveling? And just looking at some more questions coming into us. Will we have another total eclipse in our lifetime? And if so, do you know when?
We'll have one in 2024 over the United States. Like you mentioned earlier in the show, about every 18 months there's an eclipse somewhere on the Earth. Some people actually take cruises to where the eclipses are happening or travel like I did. But the next one over the United States is going to be in 7 years in 2024. And if you can wait until 2045, there will be one that goes right over Florida.
Question from Thaddeus. Can you tell us why it's getting hotter at some moments and hotter at others? And I guess that's in relation to the sun's rays being, casting down on Earth, but then also being, refracted, deflected, bouncing off of Earth's surface. Mr. Risch, would you like to elaborate?
Yes. So you know that the sun is what warms up the Earth. If there was no sun, the Earth would be frozen. During the eclipse, as the sun gets more and more covered up, and as the moon's shadow speeds along the Earth's surface, there's less and less sunlight hitting the Earth's surface in the path of that shadow. And when you have less and less sunlight hitting, the Earth isn't getting as warmed up as it normally is. And so it gets cooler and cooler, kind of like at nighttime. But the totality is so short that it can't cool off for very long. So it only drops about 5 degrees. That's what my thermometer was telling me, about 5 degrees. And then it starts to jump right back up as soon as the sun comes back out from behind the moon.
And I'll add to that with a brief that was published in Science News this week. Physicists have been studying the corona and studying the sun's energy for about 150 years. And the sun cycles, just like the Earth goes through cycles, the moon goes through lunar cycles. The sun's energy actually cycles about every 11 years. So if you consider that, based on the magnetic fields and the magnetic energy that's being released from the sun, there are times when the sun's warmer. There are times when the sun is a little cooler. But still, we're talking about 5 to tens and thousands of degrees Celsius. But in 150 years, the sun has only cycled, approximately a dozen times or so. So there's still a lot that we're trying to learn, and scientists are hoping that this total solar eclipse gives them a chance to study the corona, to take some readings, to make some observations, and then study those readings, and hopefully learn more about the sun, the solar system, and its relationship here on Earth. Mr. Risch, what's it looking like now in your neck of the woods?
It's looking a lot brighter. It's looking almost like daylight right now, regular daylight. Interesting thing, somebody had asked about animal behavior. I just noticed a spider crawling across the pavement. It was a type of spider that normally likes to hide in shadows and stuff like that and come out only at night. And it looks like he had come out during the eclipse and he was creeping back into the grass where there's some shadows. So I saw a lot of changes in the insect behavior especially.
And another question coming to us this time from Loretta. Loretta asks, what will happen if you're on the moon when the eclipse happens?
Hi, Loretta. So the eclipse on the moon is not really going to look like anything special because the moon is casting the shadow on the Earth. And the Earth is where the shadow is hitting, so the Earth is where the eclipse is really special. On the moon, it's always going to be the way it always is, and that's that it's going to depend on what side of the moon you're on. If you're on the side facing the sun, it'll be really bright. It'll be something like 290 degrees, and on the far side of the moon away from the sun, it's going to drop down to about the same temperature below zero. So there's a really bright, really hot side of the moon, and there's a really dark, really cool side of the moon. And it takes about a month for the moon to rotate. So a day on the moon is about 15 days.
Yeah, and a similar question, how long does the total eclipse last, and is it the same wherever you view it? Well, keep in mind that we have three celestial bodies involved in this solar eclipse event. You've got the sun, you've got the moon, and you've got the earth. And two of those objects are moving. You've got the earth rotating and orbiting. You've also got the moon rotating and orbiting the earth. And so because of all that movement, depending on where you stand on North America and where you're watching the total eclipse from, that timing event might change. As you heard Mr. Risch report earlier from Missouri, he saw the totality event for about 2 minutes. There's other parts of the country that might see it up to about 2.5, 2 minutes and 40 seconds. So it just depends on where you're standing, depends on the rate of speed that the Earth is rotating. It also depends on the rate of speed that the moon's shadow is moving across the Earth. So those things all together help to change and alter the timing of this event just a little bit. So again, if you're just joining us, we're here live on Lee Schools TV, bringing you a special presentation on the total solar eclipse that's occurring in the middle part of the United States. Here locally in Southwest Florida, we're experiencing about a partial eclipse. About 76% of the sun is being blocked by the moon today. And joining us live on the phone is Mr. Aaron Risch, middle school teacher at Caloosa Middle School. Mr. Risch, what's going on now in Missouri? Describe your conditions.
It's looking like pretty much daylight right now, maybe a little bit fainter than normal daylight. The temperature is still rising. It's rising more slowly, I think, than it was dropping, probably because it cooled off a little bit. Now it's having to warm up because the Earth also loses heat while the sun's not shining directly on the Earth.
Some more questions coming to us, this time from Challenger Middle School. Is it safe to take pictures with your cell phone during the eclipse?
Hi, Challenger. The only time when it's safe to take pictures without a special filter would be during totality. During the rest of the eclipse, the sun is too bright and it could damage the special chip inside your camera that records it. And I tried to take pictures during totality, and unfortunately, my camera just couldn't get a focus on it, so I didn't get any pictures.
And just to reiterate, some questions coming into us about travel during the solar eclipse. Just like any day in Southwest Florida, it's usually very sunny. We wear our sunglasses and we tend not to look directly at the sun. But because of today's event, because of today's natural phenomena, more and more people are looking towards the sun because they want to see the eclipse. And that brings with it some safety concerns. So again, if you're out there watching the eclipse, whether it's here in Southwest Florida or elsewhere, you want to make sure you're wearing your approved safety glasses and you're using those glasses that have the filters so that you're not going to be damaged by the UV sunlight. People who are driving today, they're probably just going about their business, but they're not looking directly at the sun. People who are flying planes are going about their business. They're just not directly looking at the sun. And if you choose to do so, please, again, make sure you're wearing those safety glasses. How would you describe the weather and also the temperature? Are you starting to see some changes?
Right. It's starting to warm up. Also, since we're getting the direct sunlight, you're getting that feel of radiative heating. Your body's being heated by direct sunlight, not just the air around it. So it's starting to feel a lot warmer to me. And the weather is a little bit cloudy, but it's the really thin clouds that don't cover up the sun. The sun can shine right through them. I can see lots of blue sky around here, so it was a really nice day to have an eclipse.
Another question coming to us from Fort Myers Middle. Cole asks, how will the eclipse affect the animals and the plants?
So some of the animals will start behaving like it's nighttime during the totality. I heard some of the daytime bugs, the cicadas, that make all that buzzing noise during the daytime. I heard them quiet down a lot as it started getting closer to the eclipse. to the totality of the eclipse. And I started hearing some nighttime bugs chirping, like crickets and things like that. And I mentioned earlier I found a spider crawling across the pavement who looked like he had come out and then went back in. Plants, they need the sun to make their food. So during that totality, they're going to go into their nighttime mode, and they're going to use the food that they've already made from the sunlight during the day.
Question coming to us from Orange River Elementary School. Why does it appear that the solar eclipse travels in a path like a straight line across the country?
So that's the shadow of the moon, and the moon is orbiting around the Earth, and also the Earth is rotating. You can think the Earth is rotating underneath the moon. Most of that path is from the Earth rotating. So where I was rotating into the moon's shadow, and then I was rotating out of the moon's shadow after totality. So it's mostly the Earth's rotation that makes that path across the Earth.
Another question coming to us from Honesty. Honesty asks, would the moon be a different color tonight? We had a similar question earlier in the program, and the answer to that question is no. Actually, the moon phase right now is a new moon. So we're seeing the dark side of the moon as we start to enter the next lunar cycle. In a few days, you'll start to see a crescent moon, and then more and more, gradually, more and more sunlight will be shining on the moon. But really, all you're seeing is the moon passing in between the sun and the Earth, and casting a shadow on Earth, and that's why we're experiencing here in Southwest Florida a partial solar eclipse. But in other parts of the country, as Mr. Risch just experienced, he got to see a total solar eclipse. But Mr. Risch, anything else you'd like to add about your feed, your equipment, your experience? How would you further describe the eclipse you just witnessed?
It's definitely worth coming and seeing the eclipse. And while my feed went down pretty early on there, so we couldn't actually see much from my telescope, I was able to see at the beginning, before the eclipse, there were some sunspots on the sun. Sunspots are these magnetic storms on the sun. They're kind of like little magnetic hurricanes, you could think of them. And they're where the magnetic field of the sun gets all twisted up, and it actually cools off the temperature of the sun just a tiny bit. Sunspots don't only happen during eclipses, they happen all the time. But those areas of the sun, since they're a little bit cooler, they look a little bit darker compared to the rest of the sun. So when you look at the sun through a special filter on a telescope, you can actually see them as little dark spots on the sun.
Mr. Risch, you have some fanfare and you have some family watching abroad. This question comes to us from Joshua. Joshua asks,
hi, Josh.
can you ask my brother why he chose the camera he's using and what other types of cameras or telescopes you could use? Josh is watching from the Greek island of Crete in the Mediterranean, so from Southwest Florida. Hello, Josh.
Hi, Josh. Good to hear from you. So the camera that I got was based on a recommendation from a forum that I go on called Cloudy Nights. The telescope is just a travel scope. It's one that I got from Orion Telescopes, and they sell some pretty good telescopes. And this travel scope fits in a backpack, which made it easy for me to transport it around and fit it all in my carry-on and everything like that. I've also got a netbook that came with the camera.
Another question coming to us from Ava. Ava is at Challenger Middle and wants to know, can you get sunburnt when you walk outside during an eclipse? And again, we just want to reiterate that the sun's rays and the energy from the sun is no different today than it would be on any other day in Southwest Florida. If you were to go outside and play outside and not wear sunscreen, there's a good chance you would get a sunburn. What's unique about today is there's a lot of interest in this solar eclipse event. So that means there's a lot of people looking towards the skies, looking at the sun, more so than we normally would on a day like today. And that because of that, there's a threat of damaging your eyes by looking straight at the sun. So please, if you're out there watching the partial solar eclipse here in Southwest Florida, or watching in other parts of the country where you're viewing this total solar eclipse, please make sure you're using your appropriate safety glasses.
Right. It's also important to know that when your eyes are being hurt by the sun, you can't feel it. You won't feel pain in your eyes. You won't feel like a burning feeling or anything like that. So if you're staring at the sun, you're hurting your eyes and you don't even know it.
Again, for those of you joining us live here on Lee Schools TV, whether it be on cable TV or on our YouTube feed, we are live bringing this special presentation of the eclipse across Northern America. Joining me on the phone live in Missouri is Mr. Aaron Risch, who's a middle school science teacher at Caloosa Middle School. And we are broadcasting a live feed from Springfield, Missouri, that's showing the moon moving further and further now away from the sun. And so that means there's more sunlight. Depending on the filter you're using or the feed, you might see some sunspots. Those are those darker spots that come through. Those are natural. Those spots are there. The sunspots grow larger and smaller depending on the energy of the sun and all the magnetic fields that are moving that energy around. The highlight of the event was that totality where you could see the corona. Scientists normally can't see the corona. It's too hot a space. Their instruments can't pick up the corona, but it's during an event like this, a total solar eclipse, that the corona becomes visible. Because scientists were very excited for that today, so they were planning lots of different types of experiments and observations to try and capture as much footage and as much information from that totality event as they could, and that's information that they'll study for years. Mr. Risch, how would you describe the totality, and what of the corona could you experience or see?
So I could see the corona, and it was about 3 times as wide as the sun normally is. The corona is out around the sun. It's almost like the sun has fur or something like that. So you see like a fuzzy shape around the sun. And that shape is about as bright as the full moon. I think that's why I had a hard time taking a picture of it with my cell phone camera. It's because the brightness is not what these cameras are made for. So it was the corona is still pretty bright, but it's only about as bright as a moon. So it's not going to hurt your eyes to look at the corona, but that's only during the totality. It definitely got cooler here. Now it's getting warmer again. You could hear changes in the noises that the insects were making. And you could even see street lights coming on. Lots of street lights were coming on. And I see only a couple of street lights still on down the road. But most of the street lights have gone back off. So all the street lights that were on sensors actually came on. And I just saw some butterflies. I think the butterflies are coming back out again. I saw lots of butterflies earlier before the eclipse.
Cool. Another question coming to us from Noah. Noah asks, why doesn't the eclipse happen everywhere? Well, again, as we've mentioned a few times throughout the telecast, about every 18 months there is a solar eclipse. Depending on the orbit and the path of the moon, that dictates where the eclipse takes place. Oftentimes it happens over water because Earth is covered by is 70% covered by water. Another thing to consider is, in analogy, if the sun is the size of a basketball, and if the Earth is the size of a tennis ball, and the moon is the size of a golf ball, well, that golf ball is passing in between the sun, the basketball, and the Earth. And so it's the golf ball, which we're saying is the moon, casting that shadow onto Earth. The other thing to consider is the moon is a lot closer, about 400 times closer to Earth than it is to the sun. And so you get, in essence, a magnification effect. And so the fact that the moon is closer to Earth, and it appears it's blocking all of the sun because of that magnification effect, and then also because of the size of the moon, it's casting a relatively small shadow on Earth. And so for this particular event, that shadow was only crossing North America, specifically from about Oregon, the state of Oregon, all the way east to the state of South Carolina. Other events happen at different times of the year, and they may pass over different parts of Earth or different continents. And so depending on where you live, you may or may not see those events.
Right. If you have one of those big globes in your classroom, If you can picture the size of that globe, the size of the moon's shadow would be about as big as a pea compared to that globe. So that's the size of the shadow moving across the United States.
And the other thing to consider is, and this has been studied for years, objects in Earth don't always move on the same path. They sometimes oscillate. There's different forces, gravitational pulls that change. And truth be told, the moon actually is moving slightly away from Earth every year. It's very, very gradual. It's a very, very slight shift, but nonetheless, that slight change is enough to cause a change in timing of these eclipses, whether it's a lunar eclipse or a solar eclipse. All those things considered lead to subtle changes in when these events occur. Also, more questions from our news@leeschools.net email inbox. We're up to about 416 submissions from our students. Students, great job today. We're really glad to see that you're engaged and you're interested in this event. Mr. Risch, would you remind us when are the upcoming solar eclipses that are going to be viewable here in the United States?
So the next major eclipse in the United States will be in 2024. That's 7 years from now. Some of you guys will have graduated from high school by then. Some of you guys might be in middle school or high school. That one the path will start down in Mexico, and it's going to go northeast. So it'll go across Illinois again. There's a few towns where they'll get to be able to see the eclipse twice in 7 years, 2 eclipses in 7 years, and it'll go up through the northeast. And after that, the next major eclipse over the United States will be in 2045. That eclipse is going to go right through Florida, so you should be able to get a really good view. Probably not from Lee County, but just driving about an hour north from there, like Tampa area and the middle of the state, you'll be able to get a good view of the eclipse.
And again, for those of you joining us live, we are here on Lee Schools TV, bringing you a special presentation of the solar eclipse across North America. You're seeing a feed from C-SPAN, which is in Charleston, South Carolina, and they're about at Totality in South Carolina. So that should give you a sense of the speed or the rate at which this eclipse event is taking place. Approximately 40 minutes ago, we reached Totality in Missouri, where Mr. Risch is reporting from, and now they're in South Carolina experiencing the Totality for themselves. Some questions coming to us about technology and taking pictures of the eclipse with cameras. Are we able to see the solar eclipse if we take a picture of it and then look at the picture? Yes, actually a lot of the footage you're seeing today is people using telescopes, people using cameras with special filters. As you heard Mr. Risch report earlier, he was using a setup with a telescope, special lenses, and a camera. And it's because of those special lenses that you're able to take the footage and then display the footage in a safe and viewable manner, which would be more appropriate than just going outside and looking straight at the solar eclipse. Mr. Risch, would you remind us of the equipment you're using and what type of filter you're using?
Right, so I had a telescope, I had a solar filter. It was called a safety film solar filter. It kind of looks like aluminum foil, and it reflects most of the sunlight back out and only lets a little bit through into the telescope through the lenses into your eyes. It's the safest kind of filter because it goes on the front of your telescope and filters most of the sunlight out before it even gets into your telescope. So there's no chance of it harming anything in your telescope or getting to your eyes and harming your eyes. I had a digital astronomical camera. You normally use it to film stars, but the sun is a star too, so lots of people use them to film the sun. It was on sort of like a camera tripod. The telescope was a travel telescope. It fits in a backpack, so it's really easy to pack it all away along with its tripod.
Another question coming to us from Madison. Madison asks, does the eclipse affect human behavior? Mr. Risch, how do you feel?
Yeah, my behavior's been affected. This was really exciting. Definitely lots of other people came out here. I think at the there was 9 cars out here. It's just sort of a small parking lot. There were 9 cars here, and everybody's left now because even though we're maybe about 40% covered, 30 to 40% covered on the sun, you know, most people have seen all that they want to see, so they're, I guess, heading home right now. I'm going to stay for the whole thing.
And we appreciate that. Thank you. Some more questions related to the sun and the sun's energy. Does the sun have more radiation during the eclipse?
No, the sun doesn't have any more radiation. The actual radiation on the sun itself doesn't get affected by the eclipse because the sun is millions of miles away from the Earth and the moon, where the moon is casting its shadow on the Earth. Now, less of the sun's radiation will get to the Earth because of the moon blocking the sun.
Another question coming to us today from Hayden. Hayden asked, would the solar eclipse do anything to the electronics, such as phones? And actually, in a news brief this week, one of the questions that scientists were asking is, what can the eclipse tell us about the corona's magnetic field? We've often heard about solar winds and magnetic fields or magnetic storms, like solar flares or solar storms. One of the things scientists want to be able to do is directly measure the forces behind those magnetic field eruptions. Researchers will be studying these using the sun's magnetic fields and recording measurements of wavelength. And actually, what has been proposed is that a lot of scientists are using radio equipment, right, for sound waves and such. But with the advent of cell phones and smartphones and more people having those types of devices, they're looking to enlist more and more citizen scientists to use apps. So it could be in future solar eclipses, people take out their phones, they hold their phones up to record those radio waves or magnetic waves to see if there's any type of fluctuation in those waves because of the solar event. Mr. Risch,
Right.
anything you'd like to add?
Yeah, so the sun's corona, which is the part that you can see during the totality, it's like the outer atmosphere of the sun, that goes over 1 million miles out into space from the surface of the sun, or what we call the surface of the sun, where we see all the light coming from. But the area of our solar system that the sun affects with its electrical charges, they call it the solar wind, that's called the heliosphere, that whole area, and the heliosphere actually goes out past Pluto. We've only had 2 spaceships leave the heliosphere of the sun so far, and that's Voyager 1 and Voyager 2.
Another question to us, to our inbox, coming from Alexander. Alexander wants to know, what could scientists learn from this solar eclipse? Well, there's all sorts of questions they could ask. They're looking at the corona. They're looking at those magnetic fields. They're looking at solar flares. They're looking at radio communication, cell phone communication. There's even some scientists who are studying Einstein's theory of relativity during this solar event. And they're not trying to disprove it, but they're trying to confirm his thinking. And that's an important value in science, is that when we do our research and we do our work, we not only want to try and find and make observations and make findings that support our thinking, but we also want to be able to replicate those experiments. And so we're now at a point in time where, you know, experimentation that was done back in 1915 is being replicated today during this solar eclipse with better equipment and better instruments and better knowledge of the way Earth's energy and the sun's energy and all that stuff comes together.
Right. And the way you can test relativity with an eclipse is that Einstein's theory, it was called the general theory of relativity, his theory, which has been tested lots and lots of times since then, which is what a theory is. It's something that's been tested many, many times, and we know it's true. So this theory that Einstein had was that something with a lot of gravity, something with a lot of mass, a really big object like the sun, bends the space around it. So it actually bends the space. And you can think of, if you stretched out like a sheet from a bed and you dropped a bowling ball in the middle of the sheet, it's going to pull down the whole sheet. And that's what we think the sun does to the space around it. Since the space bends, that means that the path that the light is traveling through space is also going to get bent. And so during the eclipse, what they've actually seen is that the path that the starlight from the stars behind the sun, the path that that starlight takes to reach our eyes gets bent a little bit. So it looks in the sky like the stars are moving a tiny bit during the eclipse. You can't see it with your regular eyes, though. You need sophisticated cameras to see that.
And if you're just joining us, we're live on Lee Schools TV, bringing you a special presentation on the North American solar eclipse. The feed you're seeing is out of the Midwest. The sun has already been blocked by the moon. The moon and sun have entered that totality event. There was already a first and a second contact by the moon moving across the sun. We're now moving towards the third and fourth. Upcoming is the fourth contact. You may see an image where there's a lot of bright light. That's the sun reemerging as the moon moves away. You're also seeing some sunspots on the image. And so we should be seeing more and more sunlight across our area, going back to a more normal sunny afternoon. Another question coming to us from Isabella, and I like this question. This is an interesting question. If the world were to stop spinning, what would the eclipse look like?
That's a really interesting question. So if the world were to stop spinning, the eclipse would be very different. You would still have eclipses on the Earth, but the eclipse would last much, much longer, because mainly the reason why the eclipse is so short is because the Earth is moving underneath that little shadow of the moon at about 1,000 miles an hour, the speed that the Earth turns. And if the Earth wasn't turning, then that shadow would just be pointed on the same part of the Earth until the moon moved out of the way of the sun. That would also mean, though, that the area where you could see the eclipse would be much, much smaller. Instead of being a whole path across the country, it would basically just be a spot on the country of about maybe 100 miles around.
Another question coming to us from Sarai. Sarai is a sixth grader. So being in sixth grade now, how many times will it most likely occur in our lifetimes?
Hi, Sarai. So there's going to be an eclipse in 2024. So you'll be able to see one. If you're in sixth grade now, you would be in. Let me do the math here. You'd be graduated, so you would be in college. And then there will be another one in 2045. So maybe you'll be a scientist by then studying the eclipse.
Another question to us coming from Justin. Justin asks, is it possible to have a lunar eclipse and a solar eclipse happen back to back?
That would be possible. You could have a lunar eclipse and a solar eclipse happen back to back. I would have to look it up to see how often that happens. But basically, with with the solar eclipse, the moon is between the Earth and the sun, so that it's blocking out the light of the sun from reaching parts of the Earth. And all the moon would have to do is spin around, go around to the other side of the Earth 15 days later, basically, half a month, and it could move into the Earth's shadow. I think that would not happen very often, though. But yeah, you could have a lunar eclipse 15 days after a solar eclipse. That would be possible.
Yeah, and sort of to piggyback on that question, Michael asks, do lunar eclipses happen more often than solar eclipses? And again, as you've heard Mr. Risch and I describe today, it's going to depend on those orbits and rotations, depending on the cycle of the moon and its orbit, and also the cycle of the Earth and its orbit around the sun in a year. Those cycles are going to sync up at different times throughout the year, leading to these types of events. So it's certainly possible.
Generally, you'll have more time to see a lunar eclipse. You'll have more opportunities to see a lunar eclipse than a solar eclipse. The reason why is because during the lunar eclipse, the moon moves through the Earth's shadow. Since the Earth is so much bigger than the moon, the Earth's shadow is also much bigger. So you'll be able to see the moon getting covered up from many different parts of the Earth.
Some more questions about safety. Why is it so important to wear safety glasses? Again, our eyes aren't used to staring at the sun. The sun is very powerful, gives off UV rays. those UV rays, when concentrated into our eyesight, can be damaging. So we want to make sure that we're wearing those safety glasses today when we're viewing here in Southwest Florida that partial eclipse. And then in other parts of the country, they may be viewing the total eclipse, which is now moving out of a total eclipse and back to a normal sunny afternoon. We want to make sure we're wearing those safety goggles. Also, some concerns from our animal lovers. Does the eclipse pose some harm to our animals? Well, yes, that is true. It could, but more than likely the animals are not aware of the eclipse, so they're probably not staring at the sun. But nonetheless, if animals were left outside, and if they were staring at the sun, whether it's today or any other day, they could induce some harm from looking at the sun.
Right. Animals normally know better than to look straight at the sun, so they normally wouldn't. The main way that the animals are affected by the eclipse is that they won't look at it, but they'll notice it getting much darker, and a lot of animals will go to sleep, and a lot of the nighttime animals will come out for a couple of minutes before they go back in.
Another question coming to us from Nicholas. Nicholas asks, why is the eclipse only every 100 years or so?
And the reason why that eclipses don't happen very often over the United States is just because the United States doesn't cover a really huge part of the Earth. Eclipses happen most often in areas that take up most of the Earth. So you're going to have most eclipses in the Pacific Ocean, which is almost half of the planet. That's where most of the eclipse paths will travel through. Somewhere about every 18 months, there is an eclipse happening somewhere on the planet. But a lot of times it'll be places where nobody lives, and it doesn't happen very often in the United States.
Another question, and we'll recap. I think we've had this earlier in the broadcast, but how long does the moon actually go over the sun for?
So it takes several hours for the moon to go over the sun, 3 or 4 hours. And the totality, the part where the moon completely blocks out the sun, depending on where you are in the path, for this one, it's anywhere from a few seconds to 2 minutes and about 40 seconds somewhere in Illinois. So that where I was, it was about 2.5 minutes. The longest eclipse ever, the longest totality, I should say, was about 7 minutes.
Another question coming to us from Marina at Three Oaks Middle School. Is the moon hotter during the eclipse?
The moon's not going to be any hotter during an eclipse than it normally is, because the sun is still just shining on the moon like usual. And there's a hot side of the moon where the sun is shining, and there's a really cold side of the moon where the sun is not shining. Now, during an eclipse, though, and also during a new moon, even when there is no eclipse, the cooler side of the moon is going to be facing towards us. The hot lit up side of the moon is facing away. That's why the moon looks black during an eclipse when it's blocking out the sun instead of all lit up.
Another question, and I may have triggered this question. Paige asks us, why is the moon moving farther away from us? Well, one thing to consider is here on Earth, our seafloors are always spreading. Part of that is because of tectonic plates and the lava that's moving, the molten lava and the molten core of Earth that's moving. And so as that seafloor spreads, creating more and more land, even island nations or islands like Hawaii are moving and drifting, albeit a very little bit each and every year, but they are moving. And it's a similar principle with planetary objects, that our moons and our planets, while they do orbit the sun and our moon orbits Earth, those paths change subtly each and every year. It may just be a little bit, very hard to detect, but there is, gravitational pull, and that amount of gravitational pull fluctuates, and therefore some years the moon might travel closer to Earth, and we see that in the example of a supermoon, right, a larger than normal full moon, and then other times of the year, we see that in a slightly smaller full moon. So it just depends on those oscillations.
And a lot of the other planets, especially Jupiter, the biggest planet, actually pull on the Earth and the Moon a tiny bit. So they're the cause of some of those movements. And the Moon, like you were saying, is moving very slowly away from the Earth. Part of the reason for that is also because the Moon and the Earth actually pull on each other. So the moon and the Earth pull on each other, and you've probably seen that with tides. Tides are when the moon pulls on some of the water on the Earth and raises up that water at high tide. And then when it's pulling it away from you, that's low tide. The same thing happens with the moon, but since there's no water on the moon, there's no tides on the moon. But the Earth is pulling on the moon, and the pull between the Earth and the moon actually slows the moon down a little bit in its orbit. And if you ever spun a yo-yo or something like that around yourself, or tied something heavy to a string and spun it around, the further out something goes in the spin, the slower it's going to spin. When it's real close to your hand, it spins really, really fast. You know, those fidget spinners, they spin really, really fast. If you made a giant fidget spinner far, far away from you, or if you were spinning around a ball or something on the end of a string, it would go much more slow. And so when you slow down the speed, that's related to the distance far away. So when the Earth and the moon pull on each other and slow each other down, the moon wants to go further away where it can move more slowly.
Another question coming to us from Breyer. Breyer asks, are scientists studying Mercury during the eclipse due to the fact that it's so close to the sun and hard to see? Earlier in the broadcast, I mentioned a news brief about 2 NASA jets that were going to fly at about 50,000 feet and fly at very fast speeds to keep up with the traveling shadow that's being caused by the moon passing in between sun and the Earth. And yes, part of why that mission is being done is so they could aim some telescopes and other scientific equipment on Mercury and try and record a thermal map of Mercury. And the reason for that is scientists are trying to inquire what Mercury is made of. It seems to be a slightly different composition than some of the other terrestrial planets. And so scientists were hoping that during this solar event, they would be able to point their instruments at Mercury and get better readings than other times of the year when it's just too bright, too hot, and there's too much interference with that equipment. Another question coming to us from Joseph. Joseph asks, could you put a UV filter on a phone and then watch the solar eclipse through the phone?
That wouldn't work very well either. The reason why is because the UV filter is great for blocking out ultraviolet light, but it still won't block out the regular visible light or the infrared light, which is what would mess up your phone. So you wouldn't want to use a UV filter over your phone either. You would need specifically a solar filter.
Another question coming to us from Harns Marsh Middle School. Harns Marsh asks us, how many years will pass between now and the next eclipse Florida can see? Well, let's put this into context for a moment. The last total solar eclipse that occurred over North America was February 26, 1979. So that was 38 years ago. And as you heard Mr. Risch and I mention earlier in the broadcast, depending on the moon's path and orbit and depending on the Earth's path and orbit and how those objects line up with the sun, there's a chance for more or less frequent eclipses. And so the next total solar eclipse that we'll have a chance to see, it'll go over parts of Florida, is going to be in April of 2024. Okay, so sometimes it happens more frequently than others. Sometimes it takes 30, 40, 50 years to happen. It all depends on how those objects align in space, and also whether or not those objects align over land and allow people to see those eclipses. Mr. Risch, how would you describe conditions in Missouri?
It's hot right now. It feels like the eclipse had never happened. It's hot. A lot of the bugs have been flying around now. I see dragonflies. I see grasshoppers, some of the little animals that maybe went to sleep or went in their burrows or holes during the eclipse. They're all flying around now like nothing had happened before. And like I mentioned, it's hot. The temperature has gone back up quite a bit. The sky is starting to clear up too.
We've talked a lot today about orbital pathways and rotation, but here's a question from Troy. Does the sun rotate?
That's a good question, Troy. Yeah, the sun does rotate. It takes a long time for the sun to rotate. If you want, you can look up just how many days it takes for the sun to rotate, but it takes days for the sun to turn. And the way that we can tell the sun rotating is by looking at those sunspots on the sun that I mentioned earlier. Through a telescope with a special filter, sunspots look like little dark spots over the sun. And they're little markers. You can use them as like a marker to see how quickly the sun is turning, because as the sun turns, they'll come into view and then they'll rotate away from view again. So, yep, the sun is rotating.
Another question coming to us from Justin. Justin asks, can the corona's magnetic field get to us on Earth during an eclipse?
That's a really good question, Justin. So the corona itself won't reach us, but like I mentioned a little bit earlier, the sun sends out electrically charged particles, little electrons and things like that, and that's called the solar wind. And the solar wind reaches us all the time. So the solar wind is always hitting the Earth. You might have heard of the auroras, the northern lights. That's caused when the solar wind is especially strong during like a solar flare time. When the solar wind is especially strong, it can reach the Earth and it can set up the northern lights. And a really strong flare has been known to interfere with cell phones and things like that.
Another question coming to us from Mariah. Mariah asks, how is a solar eclipse and a lunar eclipse similar? Well, I guess you'd say the way they're similar is there's one object casting a shadow on another object. But the way they're different is in a solar eclipse, the moon is passing between the sun and the Earth. So it's the moon's shadow that is being casted on Earth. And the other appearance from that angle is that the moon appears to be blocking the sun. Okay. During a lunar eclipse, it's a different arrangement of celestial bodies, and that's where the Earth is actually passing in between the sun and the moon, and the Earth is casting its shadow on the moon, hence the reason it's called a lunar eclipse. So, Mr. Risch, when you started the school year, did you ever think you'd be in Missouri following a total solar eclipse?
I thought it was going to be North Carolina, actually, but I'd asked my principal, Dr. Cole, who's really awesome. I'd asked Dr. Cole before the summer came around, because scientists know about the eclipse when they're coming ahead of time because they can figure it out with math. So I asked my principal if I could do it. She said yes, because she loves all kinds of cool science things. So Dr. Cole said yes. So I had already been planning it over the summer.
Now, earlier in the broadcast, you mentioned what you thought you saw were sharp shadows. You mentioned that as more and more of the sun was being covered up by the moon, that you noticed by looking through the leaves that there seemed to be shadows, or the same image was being cast. Could you explain how that happens?
Right. So that's called the pinhole camera effect, which is basically that if you poke a small hole in anything, if you let a small amount of light through, it acts kind of like a lens, and it'll actually focus through that hole, and it'll project an image of whatever you're seeing on the ground. They call it the pinhole camera effect because that's how the first cameras worked. Before they had film and lenses in cameras, they would just use a pinhole. Kids in school a long time ago used to actually make those pinhole cameras and try and take pictures with them. So you could see that effect. Also, the reason why some of the shadows were much sharper than they normally are is because when you're getting very close to the totality, those shadows, they're sharpened because the sun is also a very much smaller point of light. It's a smaller source of light, and so it's a little bit less blurred out. Basically, the size of the shadow, the edge of the shadow, anytime you see a shadow blurring on the ground, it's about as big as the sun is in the sky. And so as the sun gets much smaller, I should say the lit up part of the sun you can see gets much smaller during the solar eclipse, that area of sunlight that's casting the shadows is also much smaller.
Again, if you're just joining us, we are live here on Lee Schools TV, bringing you a special presentation on the total solar eclipse that's passing over North America this afternoon. My name is Lee Hughes, Program Administrator in our Intervention Program, And joining me live on the phone is Mr. Aaron Risch, science teacher from Caloosa Middle School. Mr. Risch is joining us from Jefferson City, Missouri, where he's been standing by and watching the total solar eclipse throughout the afternoon. Also, students have been sending us their questions from the classroom. They've been sending those questions to news@leeschools.net. We want to thank you, students, for being engaged in this natural phenomenon and following along with us on YouTube and Lee Schools TV. Michael asks, and this is a very interesting question as well, do aquatic creatures act up like land animals do?
That's a really interesting question, and to tell the truth, I don't know. I would think that they probably would, but I don't know the answer to that question. That might be something for you to find out.
Sounds like a science fair question or project. Some more questions coming into us from students. Let's see. What would we observe of a lunar eclipse if we were on Mars? That question comes to us from Brooklyn.
So a lunar eclipse on Mars, you would probably, well, it would depend on where Mars would be compared to the Earth. Most of the time, you would probably just be able to look from Mars and see the Earth and the Moon very close together. And the Earth and the Moon would basically look like very bright stars in the sky. The Earth would be a bright blue star because the Earth is mostly ocean, and the Moon would look like a bright white star. And you'd be able to see them close together. But that's how you would normally see the Earth and the Moon anyway. When it would be really interesting from Mars would be during one of what's called a lunar occultation. That's when from Earth, you would see the Moon passing in front of Mars. And on Mars, so it's almost like an eclipse of Mars, on Mars, you would be able to see the Moon move in front of the Earth. And so you would see the Earth get covered up by the Moon, but like I said, they're both tiny stars. So basically what you would see would be the little star that's the Moon running into the little star that's the Earth, and then they would get a little bit dimmer because the Moon would be blocking out some of the Earth. But mostly from the Moon, it wouldn't be very interesting, or from Mars, it wouldn't be very interesting to look at.
I'm getting some text messages that suggest the dolphins and whales would rise to the surface of the oceans and watch the eclipse just like the rest of us. Thank you for that. Well, again, I want to thank you all. My name is Lee Hughes, and joining me today is Mr. Aaron Risch, teacher at Caloosa Middle School. We have been proud to present to you this live look at the total solar eclipse across North America. We want to thank you all for joining us today. And again, we hope you enjoy the rest of your afternoon. Please stay safe. Please use those safety goggles and glasses if you're still looking at the eclipse. And before we wrap up, Mr. Risch, any last words, any comments about your experience today?
It was definitely great. It's a once in a lifetime thing. If you ever get the opportunity to see one, I definitely encourage you to come out and see it. I want to thank all the kids of Lee County for listening in. I want to thank my brother for emailing in a little bit earlier. That was really cool. I didn't expect that. And I want to thank all of my students back at Caloosa. You guys are great. You guys are an inspiration. And really, if it wasn't for you guys, teachers wouldn't get to do cool stuff like this.
Very well said. Well, thank you for calling in and joining us. Thank you for bringing us some live feeds today. And to all our students and to all Lee County, have a great day and a great year. Take care. Bye-bye.
Bye.